Hi, students, and how are you today? We're going to start out with a fun do now. Today is National Awkward Moments Day. Really? What? Awkward moments? We've all had them. So let's laugh at ourselves and have some fun. After we work on our do now, our objective will be to continue our mixed practice with monomials, mostly division, and our essential question will ask how I can perform addition, subtraction, multiplication, and division on monomials. We will complete a do now, complete a work page, complete your exit ticket, and the most important thing, show your work to the teacher. Now, I noticed that a lot of people are joining us that haven't been in school. So I'm going to remind you again, your do now and your exit ticket are done in this software. You use the draw feature or the type feature, and you do it in Teams. But your work page is done on paper, and that's what you have to show to me. So make sure you have your notes. If you don't finish, complete it at home, you can send me a photograph to my email, goldj@newlondon.org. So I also have a little surprise. If you finish your work, you can create your own awkward moments emoji or complete the following phrase. If we have a minute, maybe I'll show you how to do those. And our exit ticket, you'll have to do some fill in the blank. So let's move on to our do now. Today is National Awkward Moments Day. Have you ever done anything awkward? For example, have you ever called the teacher mom or dad? And yes, that happens. Have you ever accidentally taken somebody else's paper and maybe even taken it home with you? Or did you ever walk into the wrong class? It happens. So, guys, why do others laugh at our awkward moments? Are they laughing at us, with us, or just enjoying the fun of the moment? And I think when you're the one that's having the awkward moment, maybe you feel like they're laughing at you. Honestly, people are just laughing to laugh. Everybody likes to laugh. Maybe don't take it so seriously. And the best thing you can do if you have an awkward moment is laugh along with them. It's embarrassing for the moment, but it's always a great story later on. So, talk about your awkward moment or reacting to awkward moments right there. So we started this yesterday. We're going to continue with it today. Let's just review actually the division rules. So when you have coefficients, the first thing you do is divide the coefficients. And the second thing you do is simplify the variables using the quotient rule. So we have 3 divided by 6, which is 1/2. And we have h 4 minus a -1. And remember, that is a 4 minus a -1. And in this case, subtracting a negative that's our not. That's not adding, not subtracting a 1. I'm adding a 1, which is 5. So 1/2 h to the 5th power. Now you can write this, you can put h in the denominator and with the 2 on the bottom. And that would be the proper way to write that. Remember, you can put a 1 under anything and it doesn't change it. In this case, we have 1 whole h and a half. So let's go on to the next one, number 18. And if you'd like to try a few, that would be great. So we have 15 over 24. And 15 is divisible by 3. and 24 is divisible by 3. 24 divided by 3 is 8, so that would be 5 over 8. And then we've got our v, 15 minus 5 is 10, and you can write it like this, 5v to the 10th power over 8. And number 19, we have negative 3r6 over 18r to the 10th. So if we just look at the negative 3 and the 18, negative 3 is divisible by itself, so that would be negative 1. 18 divided by 3 is 6, so that would be a negative 1 over 6. And let me erase what I just wrote so we can see the letters. We have these r terms, r to the 6 minus 10, which equals 6 minus 10 is negative 4. So let's write that negative 4 here. Now, we need to make this a positive exponent. So what we're going to do is we're going to have a fraction with the negative 1 on top and 6r to the 4th as a denominator. And that takes care of that negative exponent. So remember, it's okay to have negative numbers. It's okay to have negative fraction. It's okay to have negative number in the numerator, but it's not okay to have a negative exponent. We simplify that. So here we have 8 and 20, and 8 is divisible by 4. 8 divided by 4 is 2. 20 divided by 4 is 5, so that's 2/5. Then we have w, and we have negative 2 minus 9. Well, negative 2 minus 9 is negative 11, so we're going to have to rewrite this one as well. We can put 2 in the numerator and 5w to the 11th power in the denominator. And number 21 and 22, I hope you try them on your own. Pause the video and try them on your own and then see how you do. So I hope you did that. So let's look at this. Number 21 is negative 28 divided by 4, which is negative 7. Now we have x to the negative 4 minus negative 4. So that's a negative 4 minus negative 4. It's not a negative 4, so we add 4. That equals 0. So that would be x to the 0 power. We'll deal with that in a few minutes. And then we have y, 5 minus 2 is 3. Now, the x to the 0 power, anything raised to the 0 power equals 1. So that would be 7 times 1 times y to the 3rd. And 1 is a multiplicative identity, so we can have an invisible 1 there. And just write this as negative 7 y to the 3rd, and that would be our final answer. And then number 22, we have 16 over 10, and 16 and 10 are both divisible by 2, so that would be 16 divided by 2 is 8, 10 divided by 2 is 5, so that would be 8 over 5, and we have m with an invisible 1, so that would be m 1 minus 2, which would be negative 1, and then n, I'll write over here, that would be negative 2 minus a negative 8. Again, we need to add. Subtracting a negative is adding. So negative 2 plus 8 is 6, so that would be n to the 6th power. So we need to rewrite this so that this m to the negative 1 goes down into the denominator with a positive exponent of 1, which will become an invisible exponent. So in our numerator, for our final answer, we will have 8 n to the 6th power. And then in our denominator, we have the 5 and the m. And as I said, the negative exponent is now positive, and we don't need to write a positive exponent of 1. So that's an invisible 1. So now we've got some mixed practice. So let's try these problems. So the first thing you want to do with this, with number 23, is we want to resolve the numerator before we divide. So 4 times 3 is 12. And I remember when we multiply exponents, we add the exponent. So that would be x 2 plus 7, so that's x to the 9th, divided by 6x to the 6th. And 12 over 6 is 2. And we have our x, 9 minus 6 is 3. And 2x to the 3rd is our final answer. I hope you try them on your own as we go along. So you should try number 24, pause the video, and then come back and see how you did. So for number 24, we have to resolve or simplify the denominator. So 4 times 7 is 28. And then we have that n. We had an invisible exponent of 1 here. 1 plus 9 is 10. So 28 n to the 10th power over, or under, 6n to the 3rd power. Now we can simplify this. Both of these are divisible by 2. So that would be 6 divided by 2 is 3. 28 divided by 2 is 14. And n to the 3rd minus 10 is negative 7. So that would be n to the negative 7th. Well, we're not going to let that negative exponent stay there. So we're going to rewrite this with 3 in the numerator and 14 n to the 7th in the denominator. And number 25. So in this case, number 25, we are going to simplify the entire left side first. So negative 18 divided by 2 is negative 9, and a to the 8th divided by a to the 3rd is a to the 5th. 8 minus 3 is 5. Now we're going to take that and we're going to multiply it by 5a squared. So negative 9 times 5 is negative 45, and a, 5 times a to the 2nd is a to the 7th, because we add those exponents. So our final answer is negative 45 a to the 7th power. So number 6, we will simplify the right side first before multiplying it by the left side. So 48 divided by 8 is 8. So I'm going to write the left side, 9w to the negative 4th times 8. And we have w with an invisible 1, so that would be 1 minus 3, which would be negative 2. Sorry, I was not focused on this for a minute. I apologize for that. Negative 2. So now we go ahead and we multiply. Can't forget our w. We multiply 9 times 8. 9 times 8 is 72. W, negative 4 plus negative 2 is negative 6. 72w to the negative 6. And we're going to have to resolve this negative exponent. So we'll write this as a numerator with 72 and w to the 6th power as the denominator. So number 27. Let's do the numerator and denominator separately. So 8 times 10 is 80. And then we have c and d to the 4th power. In our denominator, we have 16, c to the 8th, d to the 2nd power. So that's what we have to simplify. So 80 divided by 16 Well, 80 divided by 16 is 5. 6 times 5 is 30, 5 times 1 is 5, and 3 is 8. So 80 over 16, let's change the color here, simplifies to 5. Then we have c to the first, we have an invisible 1 here, minus c to the 8th is c to the negative 7th. D to the 4th minus d to the 2nd divided by d to the 2nd, so we subtract 2 from 4 would be d to the 2nd. So when we do a final rewrite, 5d to the 2nd stays in the numerator and c goes in the denominator with a positive exponent of 7, and that's it. So in the next one, number 28, we have 6r to the negative first power times negative 8s to the sixth power. In the denominator, we have 10r to the fourth power times 4s to the negative third power. So let's do the numerator first. 6 times 8 is 48. And then we have that r to the negative first power. And we have that s to the sixth power. Now we'll do the denominator. 10 times 4 is 40. And we have r to the fourth power, s to the negative third power. So 48 divided by 40, both of those are divisible by 8. So 48 divided by 8 is 6. 40 divided by 8 is 5. So our fraction will be 6 over 5. And we have r, negative 1 minus 4. So negative 1 minus 4 is negative 5. So r to the negative fifth power, s to the sixth minus negative 3. Okay, remember, if there's a negative in the denominator, then that we're going to have this situation where we subtract a negative. It's not negative 3, it's 6 plus 3, which is s to the ninth. So the 6 can stay in the numerator, the s to the ninth can stay in the numerator, but the 5 and the r to the fifth will go into the denominator. So 6s to the ninth, and then the denominator of 5r to the fifth power. And that will then be a positive exponent because it's been put into the denominator. And number 29, let's resolve the left side. So 15 divided by 3 is 5. And then we have our x, 10 minus 5 is 5. And then we have our y, 8 minus 2 is 6. So we have, I'm going to write it over here, 5x to the fifth, y to the sixth. Then I'll write the rest of the problem, minus 7x to the fifth, y to the sixth. Now, what we have here are like terms, x to the fifth, y to the sixth. So 5 minus 7 equals negative 2, and that would be x to the fifth, y to the sixth. And finally, number 30. Got a lot of letters there, so let's go through it carefully. 40m to the negative first power, n to the fifth power. So that's one quantity. The second quantity, 2m to the fourth, n to the second power, plus 11m to the third, n to the seventh power. So remember, we do our multiplication and division before we do addition and subtraction. We don't have division, but we do have multiplication, and we save the addition for last. So 4 times 2 is 8. Now the m's, we add the exponent. Negative 1 plus 4 is 3. n, 5 plus 2 is 7. So we have that term plus, we'll finish it up, 11m to the third, n to the seventh. And here we see that we have like terms, m to the third, n to the seventh. And it's an addition problem, so 8 plus 11 is 19, m to the third, n to the seventh. So let's go back and finish our exit ticket. When I add or subtract monomials, they must contain like terms. When I multiply monomials, I add the exponents. When I divide monomials, I subtract the exponents. And then I did give you a little fun to have at the end. So if you finished on time, you can create your own awkward moments emoji and make it look fun and just have a good time with that. And then also, I don't know if you've ever done one of these fallen phrases. So what you need to do is figure out what letters go in what boxes. It's often best to start with smaller letters. So here I have a box with 2 letters, and I see that I can make the word an, A-N. So I'll put those here. You could do this on paper or use the draw tool. So now I only have 2 letters left that go in these 2 boxes up here. So you figure which ones are going to go there. So this is all about awkward moments. So I'm wondering if the word awkward is in there. That would be AWKWARD. So look at that. These letters can go straight. So the letters in each column can only go in the column right above. Okay? So I know that this has to be an A. So that's done. So I'm thinking this is the word awkward right here. This is a D, so I can cross those out. And then you just keep moving on, trying to use the letters in the same column, okay? So just work with smaller words first, do some guessing, and I think you'll find it's a really good phrase. So anyway, you've worked hard. I appreciate your hard work. I appreciate all your kind words, and I appreciate how you're thinking about math, but you're thinking about other things too that help us grow up and get along with others, and just celebrating those little moments at school. I very much respect and admire that you've chosen that this year, as crazy as things are this year, you're here to learn. You're here to take advantage of the small classes and really focusing on what the teacher has to offer and doing what you're supposed to do. You're really getting ready for high school. So keep on practicing and you'll be great.